This is a video from section 3.3, and this video will have examples that involve two special trigonometric limits. We're going to start with number 1, the limit as x goes to 0 of sine x divided by x. In this limit, by the way, notice how the argument for sine is x, the denominator is x, and so they match, and you get 1. Now, by the way, if that's true, I want to also make note here, I claim the limit as x goes to 0 of x over sine x is also 1. We're going to need that, okay? And then on number 2, the limit is x goes to 0 of cosine x minus 1 divided by x. That's equal to 0. And so these examples will involve these two special limits. Let's take a look at example 1. So if I take the limit as x goes to 0 of sine 5x divided by 3x. Well, I'm looking at the argument for sine as 5x, but the denominator is 3x. And so the argument and the denominator don't match. And so what I'm going to do is I'm going to take a third out, right? Because that 3 is in the denominator. And so I'm going to multiply a third times the limit as x goes to 0 of sine 5x divided by x. But I want to make the argument for sine and the denominator match. And so in order to do that, I need to multiply the denominator by 5. But if I multiply the denominator by 5, I got to multiply the limit by 5 to counterbalance. And so what I'm going to do here, I'm going to create a little room, is I'm going to multiply this limit by 5. Right? Because basically what I did was I multiplied by 1. And anytime you multiply by 1, the number doesn't change, or the value doesn't change. And so you have 5/3 times the limit as x goes to 0 of sine 5x divided by 5x. And notice how the argument for the sine is 5x and the denominator is 5x, so they match. And so what you get, this is equal to 5/3 multiplied by 1. And so the answer is 5/3. And that's how you do example 1. Example 2. Suppose I had the limit as x goes to 0 of sine x divided by sine pi x. And so I'm going to break this apart as follows. So we get the limit as x goes to 0. Remember, x is not 0. X is approaching 0. That's very important. So I'm going to take the limit as x goes to 0 of sine x over 1 times 1 over sine pi x. And so if we go back, right, I know that limit. The limit as x goes to 0 of sine x over x is 1. And so what I'm going to do is I'm going to multiply the denominator by x. So I'm going to put an x there. But if you multiply the denominator by x, I got to multiply the numerator by x so that they match. Now, if this first factor is covered, and so we got to look at this guy here. And so let's break it apart first before we look at it, though. So we get the limit as x goes to 0 of sine x divided by x times the limit as x goes to 0 of x over sine pi x. So let's take a look at it in pieces. Now, as x goes to 0, sine x over x goes to 1. So we have a 1 there. Now, the argument for the sine is pi x, and so I need the numerator to have a pi x in it. And so to do that, I'm going to put a pi there. Now the argument for the sine and the numerator match, but if you multiply the numerator by pi, you got to multiply the limit by 1 over pi. So I'm going to put a 1 over pi on the outside, because remember that 1 over pi times pi is 1, right? And when you multiply by 1, you don't change anything. And so this is equal to 1 times 1 over pi multiplied by, now as x goes to 0, that quotient will go to 1, right? So you're going to multiply by 1. And so the answer here is 1 over pi. And I'm done. That's how you do example 2. Example 3. Suppose I have the limit as x goes to 0 of sine squared of 3x divided by x. And so what I'm going to do here is I'm going to rewrite this as follows. So this is the limit as x goes to 0 of sine of 3x divided by x times sine of 3x. Now, so by the way, it's the limit of the whole thing. Now, the argument for the sine is 3x, and I have an x in the bottom. So I need to make sure to have a 3x in the bottom, because I need the argument for the sine and the denominator to match. So if I put a 3 there, I need to put a 3 on the outside of the limit. Okay? And so now they match, and then that first factor goes to 1, it turns out. So this is 3 times the limit as x goes to 0 of sine 3x divided by 3x. And I'm going to multiply by the limit as x goes to 0 of sine 3x. So this ends up being 3 times, as x goes to 0, sine of 3x over 3x goes to 1. So you get 3 times 1. And as x goes to 0, this sine of 3x goes to 0. So you're multiplying by 0. So the answer is 0. That's how you do example 3. If we take a look at example 4, there's some good problems in here. So if I take a look at the limit as x goes to 0 of, let's do this one, 1 minus secant x divided by 2x. And so what I'm going to do is I'm going to move that a 1/2 basically to the outside. And then if you guys don't mind, one more thing I'm going to do is I'm going to rewrite secant x as 1 over cosine x. And then I'm going to divide by x. And so I'm going to clear that fraction by multiplying the numerator and denominator by cosine x. And so this is 1/2 the limit as x goes to 0. Now, I'm going to distribute the cosine in. And so I get cosine x minus 1 divided by x cosine x. Okay? Now, this is 1/2 the limit as x goes to 0 of cosine x minus 1 divided by x times the limit as x goes to 0 of 1 over cosine x. And I hope that's okay, because the cosine x is appearing in the denominator. Now, this first limit goes to 0. The second limit goes to 1 because cosine of 0 is 1. And so this is equal to 1/2 times 0 times 1. And so the answer is 0. And that's how you do that question. Example 5. Suppose I had the following. The limit as x goes to 0 of sine 3x times sine 5x divided by x squared. This is a great question. So this is what I do. I'm going to take a look at the limit as x goes to 0 of the following. So this is sine 3x times sine 5x divided by x times x. Okay? Now, notice how the argument for the sine is 3x, and so I need a 3x in the denominator. So I'm going to put a 3 there. So notice how the argument for the sine and the denominator match. Now, the argument for the other sine is 5x, and so I need a 5x in the denominator. So I'm going to put a 5 over there. But notice how 3 times 5 is 15, and so I got to multiply the outer limit by 15. So I'm going to put a 15 on the outside. And that counterbalances what I multiplied in the denominator. And so this is the limit. Well, let's put a 15 there first, right? So we're going to put 15 times the limit as x goes to 0. Now, we get sine 3x divided by 3x times sine 5x divided by 5x. Now, if you guys don't mind, notice how I'm going to take the limit of the first, essentially factor, times the limit of the second factor. So as x goes to 0, this first piece goes to 1. The second piece goes to 1. And so in total, this goes to 15 times 1 times 1. And so the answer here is 15. And that's how you would do the fifth example. Let's take a look at number 6. Suppose I had the following. The limit as x goes to 0 of sine 3x divided by 5x cubed minus 4x. And so I'm going to factor an x out of the denominator. And so I'm going to take the limit as x goes to 0. I'm going to take sine 3x divided by x times 5x squared minus 4. just like this. So now, the argument for the sine is 3x, and so I need a 3 there in the denominator. So I'm going to put it here. But if I divide by 3, I need to multiply the limit by 3. And so here you get 3 times the limit as x goes to 0 of sine 3x divided by 3x times 5x squared minus 4. But as x goes to 0, this piece goes to 1. Okay? Now, and then I just got to plug in 0 in that 5x squared minus 4. And so what you end up getting is the following. You get 3 times 1 divided by 5 times 0 squared minus 4. And so the answer here, this is going to equal negative 3/4. And that's how you do number 6. Let's do a couple more. So we'll take a look at number 7. Suppose I had the limit as x goes to 0 of cosecant x times sine of the sine of x. This one looks a little deceptive. And so what I'm going to do is I'm going to view cosecant x as 1 over sine x. And so I'm going to rewrite this limit as the limit as x goes to 0 of sine of the sine x divided by sine x. Just like this. Notice how the argument for the sine is sine x and the denominator is sine x, and so they match, right? So I claim this limit ends up being 1. So that's kind of an interesting one. Let's take a look at number 8. Suppose I had here's a great question. Suppose I had the limit as x goes to 0 of sine of x squared divided by x. Notice how the argument for the sine is x squared, but the denominator is x? They don't match. And so what I need to do is multiply the denominator by x. The tricky thing here is you don't want to multiply that limit by x. That's not true. If it's a constant, you could do that. But when it's an x, you cannot do that. And so what you need to do here to make an adjustment is you're going to multiply the denominator and numerator both by x. But it's got to stay inside the limit. And so here, I'm going to take the limit as x goes to 0 of x sine of x squared divided by x squared. X times x is x squared. And as x goes to 0, this piece right here goes to 1. Okay? And as x goes to 0, this goes to 0, what I have circled. And so the correct answer here is 0 times 1, which is equal to 0. And that's how you do problem 8. And let's do one more. Problem 9. So if I take a look at this one, the limit as theta goes to 0 of cosine theta minus 1 divided by 2 theta squared. Now, there's a couple of options here that we can do. And so this is the limit as theta goes to 0 of cosine theta minus 1 divided by theta times 1 over 2 theta. All right, I found a better way to do this. So I thought of a better way. So we're going to do this. So I'm going to multiply the numerator and denominator by cosine theta plus 1. Okay? And so you get the limit as theta goes to 0 of. So you get cosine squared theta minus 1 divided by 2 theta squared times cosine theta plus 1. Now, cosine squared theta minus 1 is negative sine squared theta. So you get the limit as theta goes to 0 of negative sine squared theta divided by 2 theta squared times cosine theta plus 1. Now, I'm going to move that negative 1/2 out in front of the limit. So this is, let's move that limit, or the negative 1/2 out in front first. So it's negative 1/2 the limit as theta goes to 0 of. Now we get sine theta times sine theta. That's sine squared theta, by the way, okay? Divided by theta times theta times cosine theta plus 1. So you get negative 1/2. Now, as theta goes to 0, sine theta over theta goes to 1. Sine theta over theta goes to 1. And cosine of 0 is 1, and then 1 plus 1 is 2. So this is going to be negative 1/2 times 1/2. And so the answer here will be negative 1/4. And that would be the correct answer for example 9. And this concludes this video for section 3.3. And this is 9 examples on finding limits. Thank you.